here to present a presentation about above contents. These are the key areas I will cover, starting from the internal components of a CPU, moving through how hardware works together, and finally ending with storage, logical gates, and networks. Internal components of a CPU. The CPU has three main internal parts. The arithmetical logical unit performs calculations and logical tasks, and the central unit. Central unit directs the system's operations, and memory unit store temporary data. Cache control manage how frequently used data in quick access. In addition, we have the main processor, the coprocessor for support, and cache RAM, which makes processing faster by storing frequently accessed data. Function of a central processing unit. Think of the CPU as the main brain. It processes data, executes commands, and temporarily stores results. It keeps the entire system function efficiently. Let us see how hardware components work together. All hardware from the CPU to RAM to peripherals are connected through the motherboard. These coordinations allow the computer to perform tasks efficiently. This slide introduces different types of storage media used in computers. There are two main categories. Primary storage includes RAM, cache, and registers. These are the fast and volatile, meaning they lost data when power is off. Each has specific purpose. RAM helps to CPU process tasks. Cache memory boosts access speed and registers hold immediate instructions. Secondary storage, unlike primary, retains data even when the computer is off. Example include hard drives, ROM and CD or DVDs. These are used for long-term storage, including the operating system, applications, and personal files. How data represented in computer system. Digital computers use binary to represent all type of data. They recognize two states, on and off, corresponding to 1 and 0. Everything from text to image is eventually converted to binary. This slide shows how analog and digital signals differ. Digital signals use discrete levels, either 0 or 1. The chart below shows a simple binary representation using time intervals. Encryption in a computer system. Encryption secures our data by converting readable text into unreadable code. This helps prevent unauthorized access. Only the intent recipient with the correct key can be decrypt the message. Representing image and sounds. Images and sounds are also stored in binary. For image, each pixel's colors is converted into binary. For sound, the analog waves is sampled at regular intervals and each sample is stored as binary. How can compressions aid the storage of data, image and sounds? Compressions reduce the size of files like image, audio and video, make it easier and faster to store and transfer data. There are two main types: audio compressions and image compression. Audio compression removes part of audio that are less noticeable to the human ear. Image compression reduces the file size while trying to keep image quality high. This helps save storage space, lower cost, and reduce transmission time. Purpose of logic gates. Logic gates are essential components in digital electronics. They help us to design circuits and process binary data. By combining gates like AND, OR, and NOT, we can create more complex logical operations to control how computers or system behave. Let us see about AND gate. The AND gate outputs 1 only if both inputs are 1. This is shown in truth table. Its Boolean expression is F equals A into B. There are four possible combinations with two inputs. OR gate. The OR gate gives an output of 1 if either or both inputs are 1. Its Boolean expression is F equal A plus B. Again, we have four combinations with two inputs. NOT gate. The NOT gate is different. It only has one input. It flips the input. If the input is 1, the output is 0, and vice versa. The Boolean expression is F equals A bar, representing the inverse. Now let us see about NAND gate. The NAND gate is a combination of AND and NOT gates. Its output 0 only when both inputs are 1. The Boolean expression is A into B bar. It's widely used because it's very versatile and can be combined to form other logic gates. The NOR gate. The NOR gate is a combination of OR AND followed by a NOT gate. Its output 1 only if both inputs are 0. The Boolean expression is A plus B bar, meaning the inverse of A or B. This is useful when we want an output only when no input signals are active. Lastly, exclusive OR gate. The XOR gate outputs 1 only when one input is 1, but not both. This gate is often used in digital logic to detect difference between two binary inputs. Purpose of different types of computer network. Computer networks are categorized by size and reach. The first one is personal area network, like Bluetooth, connecting phone to headphones. The second one is logical area network, connects device within a home or building. Man, converse a city or campus. Lastly, wireless LAN, like Wi-Fi, similar to LAN but without wires. Each network types serve different needs depending on range and connectivity requirement. Hardware, software, and transmission media used in a computer network. To build a computer network, we need hardware like router, switch, bridge, network operation systems, protocol suites. Router directs data across networks. Above switch connect multiple devices within a network. Bridge connects different networks for software. Network operating systems manage device and data. Protocol suites like TCP, IP, which ensure smooth communication. Range of World Wide Web technologies. The WWW is a global system of connected web page. Two key technology behind it are web browsers and HTML. Network topologies. The slide shows the different types of network topologies. A topology is the way computers are connected in a network. The common one is bus, star, ring, mesh, tree, and point to point. Purpose of each topology has different purpose. Bus topology, all devices share one line. It's cheap but slow. Star topology, devices connect to a central hub. It's more reliable. Ring topology, data moves in circle. It can be fast, but one issue can affect all. Mesh topology, every devices connect to others. It's strong and used in wireless networks. Tree topology, a mix of star topologies in a tree shape. It's used to large networks. This is the ending of my presentation. Thank you for listening.